Every example that we've done so far has worked out well. We have come up with an expected value, and it has been a number. It turns out there are some distributions where things don't work out well, and your expected value or your population mean does not exist. Here are probably the two most famous examples of that situation. First example, find the expected value of x for the Pareto random variable x with a probability density function that looks like this. Now, the Pareto distribution is used to model incomes. This number over here is generally going to be a minimum wage, and the shape of this distribution will tell you whether everybody is tightly clustered around the minimum wage or spread out more or less. This is a special case of the Pareto distribution. Well, to find its population mean or expected value of x, and that is of course mu, expected value of x, you will integrate from 1 to infinity. That is, integrate over the support of x times f of x dx, and this works out to the integral from 1 to infinity of 1 over x dx. You recognize this from calculus as something that diverges, which means that in this case we do not have a population mean or an expected value for this distribution. As a second example, consider finding the expected value of x for the Cauchy distribution. And here is the Cauchy distribution. This one goes from minus infinity to infinity, and the probability density function is 1 over pi times 1 plus x squared. The Cauchy distribution happens to be a special case of the t distribution, sometimes called the student t distribution, with 1 degree of freedom, and we will see that distribution later in the course. In any case, to find the population mean, once again, that is going to be mu, or the expected value of x. It's the integral over the support, and the support goes from minus infinity to infinity, of x multiplied by the probability density function f of x dx. And you can see that if you put a 2x and balance it with a 2 down here, pull that 2 pi out front, you've now got a 1 over u du type of integral. And so that will be the log, and by the way, this should be the natural logarithm here, of 1 plus x squared. And when you evaluate that at positive infinity and negative infinity, that in fact also diverges. So we have another random variable here where you have a mean that does not exist. Fortunately, this is fairly rare, but these are two famous cases, namely the Pareto distribution and the Cauchy distribution, where you have an expected value or a mean that does not exist.